petrol-powered vehicles to date, the bicycle is the most successful. The Comte de Sivrac, a French nobleman, started the two-wheel craze nearly 200 years ago. The thing wouldn't go uphill, it didn't turn, and with no brakes, it was a mite dangerous downhill. A German baron, von Drey, made one you could steer by 1820. He used it to boundary ride the property. Then, by 1840, a Scots blacksmith, Kirkpatrick Macmillan, put pedals on it. But he only built two. Too small, too expensive. Each attempted a different answer to reduce wheel size without losing speed and to move the rider's weight back for safety's sake. But penny farthings were the ordinary style of bike. They looked anything but ordinary and had very nasty habits. Bikes are an inventor's paradise. All sorts of variations appeared. Until the Rover Safety of 1885 set the basic classic pattern that is still followed today. Refinement continues, materials change, but the modern bike is a direct design descendant of the Rover. Important industrial techniques and inventions have come through the years from bicycle technology. And from the turn of the century, bike shop men like Henry Ford, William Morris. Glenn Curtis and the Wright brothers built their new machines. A twin bike ambulance ran to Cobar Hospital in outback New South Wales. And pedal-powered generators drove the AIM Flying Doctor transmitters. Pedal boats have crossed the English Channel, and experimenters have flown a few hundred meters in pedal planes. All this because of the potential energy efficiency of the chain drive. A person on a bicycle uses 1/5 the energy of a man walking. In terms of calories used, the bike and rider outperform all other travelers. A bike cannot balance by itself, but if given sufficient forward momentum, control becomes simple. Forward drive is provided by rotating pedals, with crank levers to an axle and a sprocketed wheel, linked by chain to a rear sprocket fixed to the driving wheel. A single high-speed gearing is poor for hill climbing, but a choice of different speeds is available through gears. The two most common in use today are the hub gears and derailleur style. Hub gears use a planet and sun system, epicyclic. Hold a coin down and run another around it, looking at the relative speeds at A and B. A sliding clutch changes the ratios inside the hub. The Sturmey Archer 3-speed hub set in middle gear, that is, direct drive. Rear derailleur gears use a hinged arm controlled by a cable to allow jockey rollers to move the chain under the required sprocket. The cage is spring-loaded to take up the chain slack. Front derailleurs push the chain sideways to switch the chain wheels. Gear ratios are described by the formula chain wheel teeth over sprocket teeth multiplied by drive wheel diameter. The result is the theoretical diameter of an imaginary drive wheel, and of course, the distance covered on the ground per revolution is its circumference. Unless it is a fixed ratio track racing bike, the rear sprocket is a free wheel, a one-way drive device. Its pawls and splines make the characteristic ticka-ticka sound when travelling, but not being pedalled. A bike can be shod with either singles or wire-on tyres. A number of different wheel rim sections are available. Singles with silk tyre cords can be as light as 150 grams each. And of the hundreds of different variations in tyres, most today are made of synthetic butyl rubber. The black tread sections have a high proportion of carbon black with its good resistance to abrasion. The more natural biscuit-coloured walls are better able to resist flexing. Tyre design requires the balance of often conflicting elements to best suit a rider's needs. Cross-spoking was invented for the bicycle to provide large but light, strong wheels. The wheel is trued circumferentially and laterally by varying tensions on the spokes. Pedals, tyres, wheels, sprockets, etc. make the bike go, but stopping it is equally vital. A racer on a fixed-wheel track bike brakes by pedalling slower, gloving the wheel and hoping. But at present, the best brakes are wheel rim squeeze systems, in principle similar to car disc brakes, except that the rim itself is the disc. The brake lever, when squeezed, shortens the cable, bringing the brake blocks into contact with the wheel. The primary advantage of center pull brakes is their smooth action. Springs hold the brakes open until the pull comes. The calipers close and the blocks tighten on the rims. Rubber brake blocks are today shaped with studs. The side pull does the same job with only one pivot point, centrally placed. Bicycle brakes should be applied evenly and both together. The front brake is more effective, but dangerous. The back brake skids easily. Other brake types act at the hub, which can be helpful in wet conditions. Disc-style, hub shoe and coaster brakes are in use today. Basic to the bike is the frame. It is both skeleton and heart. Most are made of steel, the best of high carbon steel. But other alloy steels and titanium are also used. More exotic frames have included bamboo, plastic, carbon fiber and laminated wood. Steel is sometimes welded at the joints, but this is a cheap and fast process, but a poor solution for bikes. Lugs are used to joint good frames. The heat required in brazing is far less than for welding. Every effort is made to minimize changes in the crystalline structure of the tubes from this heating. Lugs vary in shape and pattern as fashions change, but their purpose is constant, to reinforce the frame joints. The frame stress points are obviously at the joints, and the impact forces are similarly concentrated at the tube ends. This led to the development of the butted tube. Seamless straight gauge tubes, tensile strength around 414 kilopascals, are common. But high carbon cold drawn seamless tubing has a tensile strength of 620 kilopascals before brazing and a minimum of 550 kilopascals after brazing. Add a buttered contour, and it's formidable indeed. Reynolds 531 is one of the better tubes. It's buttered at both ends, and the steel used is a manganese. Molybdenum alloy steel and its composition includes approximately 0.25% carbon, 1.33% manganese, 0.2% molybdenum, 0.27% silicon, and a maximum of 0.045% sulfur and phosphorus. The frame's bottom bracket takes the chainwheel axle. The head tube mounts the handlebar stem, steering tube and forks, while the seat tube bolt grips the seat post in position. The backstays hold forged dropouts of varying designs. Frame designs change to the purpose of the bicycle. The double triangle diamond is the most used and can support a mass of 2 tons. But the swinging load a fast-pedaling sprint delivers causes violent thrust side to side. The degree of whipping is a problem in the current design. Too stiff, and it will jolt and fight the rider. Too springy, and it will run jerkily and absorb the drive energy. To feel the whip response on a bike, plant it firmly and push the bottom bracket. Go easy. Feel the displacement and the recovery. The quicker the better for riding. In comparing these typical frame designs, notice the variations in fork offset, wheelbase, and tube angles. Speed or comfort demand different design criteria. All of the dimensions can vary to the rider's physical size and to best suit his purposed use for the bike. The longer the wheelbase, the softer the ride. Steeper angles mean greater efficiency in power. Variations in fork offset affect the steering. Here are some current Repco design solutions. Step-through designs suit all the family and allow for adjustment to fit the rider's size. A road racer needs high-speed, close gear ranges, plus optimum lightness and strength, while a tourer has a more relaxed approach in all departments. It is essential that a bike fits its rider. Frame size needs to be right, with seat and handlebars adjusted carefully. For power, the seat should be spaced from the pedal about 8% more than the rider's inside leg measurement, so that the leg is at almost full stretch when the pedal is lowest. Care, thought, good materials, good paintwork, good chroming, and experience lead to good bikes. And a good bike kept clean and tight will run almost indefinitely. In review, these are the bicycle's major components: frame, wheels, drive sequence, brakes, a seat to sit on, and handlebars to grip. Component materials vary, each in its turn providing different advantages. Frame and forks are mostly of steel. The exotics are generally expensive and not always successful. But the bike has shown